And a lot of universities, mainly with engineering, to be truthful, have remote access to their labs, so the students log on or have the
and make the experiment by their
actuate the apparatus. And that could be anywhere in the world. And they have a booking system, so you can book it at 3 o'clock in the morning if you want to, because you're in a different time zone. When you say remote control, could you do it like just be on the same network, or could you be anywhere in the world to do it? You have to be on the LAN, or can you be?
At the moment, only for in the same network. That's the first step.
Right.
But the second step might be that we also come from outside the network and have an entrance and are able to control it.
Because it could be application for some of our customers. Like some of our, particularly the universities that aren't in the major cities or in the rural areas.
Activity manager, I think my colleagues have shown it to you on Monday. Activity manager, where all the the descriptions are inside. And if you now so we have started with open the software, switch on the device, and now you are able to choose an experiment from phywe or do a quick start with the experiment. Let's quick start. Quick start means you can choose any channels you want. Expert link, you have coming with 4 channels, 2 for the current, 2 for the voltage, and the possibility to connect over adapter any copper 4 sensor you want. So at the moment you only have these 4 channels because you have no connection to any sensors of copper 4. So, and what I want to do is I want to study the charging curve of a capacitor. It's like this circuit here. I want to charge the capacitor and I want to measure the current and the voltage. So for this I use the channel 1 and the channel 3, for example. 3. Okay. And then the device is connected and can start. What is also part of the expert link, it's a switch which is inside the expert link. You can control the switch from software side.
Okay. So you got that. You have to put that bridge in, do you, to make the switch work?
No, the bridge is only the switch comes later.
Okay.
The switch works also.
Right. Okay.
Close means light is on. Current and my voltage. Let's start with the voltage. In parallel, of course.
כרגע אנחנו מבצעים בדיקת וולט שהיא נמצאת במקביל למעגל.
Now I need a circuit. So for this I go the current.
בדיקת אום שתהיה חלק מתוך המעגל בטור.
But I don't have a power on the circuit. So I have to put the power on the circuit. For this I use the 5 volts coming from the device. So. What? Go on. What you normally do is you put the power on your circuit.
Because it's not certified for use in medicine.
This is your circuit.
Yep.
Normally you need a switch. So here you have a switch, switch on, switch is closed, switch is open. So now you want to use the expert link to supply this circuit with power.
אז הוא למעשה כרגע מחבר את
bridge.
הסוויץ'.
So now I'm at 5 volts, and then go to the earth.
Right, so that 5 volts, that's a supply.
Yeah, that's supply. So this is the same circuit. No, this is the same circuit I have shown to you with this guy here. 0 plus 5 volts.
Right, okay,
Now I need a switch. I take the switch which comes from the device.
got you. Right,
So, okay. So now I want to measure the voltage. Again, the voltage in parallel to the capacitor. And now I have to also measure the current, which is in series. Therefore, I go put the current measuring device in series.
Yep.
That's the experiment.
right, got you.
Okay, so yeah, if I now switch on, the capacitor is minus 5 volts, so plus 5 volts. So, what I can do now is I can
So that capacitor is discharging now.
yeah, it's discharging now, of course, yeah. So we can okay. So now I can use trigger settings, which triggers the falling and rising of current, the pre-trigger, to measure my curves, or I take an experiment which is prepared by phywe. For this, I do phywe experiments. Okay, for example, this is mine. It's similar, just to go. Similar. This is the capacitor and the resistor. I'll use the same bridge here. Okay. I click and any thing will be pre-configured to start immediately with the
Are
experiment.
those capacitors, can you take them out and plug them in? Are they fixed to that?
Discharge. Okay, I now start experiment. Nothing happens because the switch is off. I will now switch on. The measuring automatically starts and stops because the trigger is set on the rising and falling of the current. And now zoom in. I got my two curves for the voltage here and the current there. And then, at the moment, we are working on some analysis functions. Yeah, you are in the testing mode if you want. But what the customer anytime can do is they can put the data sets which are measured and take it and put it in Excel or any other analysis programs. For this, you can use the data pool here on the right-hand side, and for example, take any.
Why did you do it with the 2 megahertz?
2 kilohertz.
2 kilohertz. Oh, but you can do it with more, no?
Yeah, of course, yeah. But you don't need 10 megahertz for this experiment because the processes you want to study are too slow. So if you use 10 megahertz, you get a lot of more data and you don't need this.
Okay.
Desktop and I open XXX, where is it here? Voltage and over the time, and I can use this to analyze anything I want. Okay. Then this is for a simple experiment. If I can also electricity. I need a supply or a power supply which generate any signal I want, like a function generator. So I can combine the expert link with the function generator and control these two devices from Measure Lab side. For this I also put the function generator in the circuit. Switch on.
Why you need the USB connection to the function generator?
To have the connection to the computer. It's not wirelessly.
Yeah, of course, but why?
Why?
Which functionality you will have it? You can program?
I want to control the function generator by the computer.
Oh,
you can
okay.
do it manually, of course, with these buttons here, but you can also do the same things from the software side.
Cool.
Okay, so, but why I need this function generator? I want to. This is. You have this is your RLC circuit, and then you have to put on this. You have to put a signal from the function generator, and then you have to measure your current and your voltage. And this is let's say the thing that you study by using the experiment RLC circuit. So, okay. So for this kind of functionalities, and this is one. And the second one is that we have prepared some experiment, some configuration for experiments to start with. In the world of HLN or in the Fluke, you have to make your own configurations, and I'm not sure at the moment if it's also possible to reload these configurations. Maybe yes, maybe no.
I'm not sure about it.
But for our software, it's every time it's possible to reload configuration which comes from our prepared experiment, but also own configurations. You can set any parameter you want in the software, and then you can save these configurations. And if you go back to the lab, load this configuration, and you can start the experiment. So the customer or the professor can, or the lab assistant can create their own experiment.
What about them saying?
You need a bridge between school and industry. This is a bridge.
Okay.
If you put these complex devices from the industry on the desk of the students and say, "Here, that's industry, make it." It makes no sense. It's not the way we want to go. The way we want to go is to building the bridge between the theory from the school or the simple experiments from the school to the more complex measuring devices from the industry.
Just in comparison to, say, a typical storage scope, what kind of cost are we looking at?
Kind of cost? 1,000 euros, this one.
Right.
And this 500, I think.
Okay. All right, so it compares favourably then to an oscilloscope.
So, as I have mentioned, we have to.
So we're adding in an inductor to this circuit.
אז תכף אנחנו נראה את השימוש בציוד המתקדם של phywe. למעשה זה מיועד למכללות, אוניברסיטאות, או אולי הנדסאים בבתי הספר מתקדמים, בגלל שהציוד הזה באמת לא הזול ביותר, ובטח שהוא גם לא הפשוט ביותר. יש פה מחולל שנשלט על ידי מחשב, שנותן לנו FMA עם כל האפנונים, נותן לנו בעצם יכולת בקרה ממוחשבת, וכמובן מתחבר לממשקים החדשים ביותר שקיימים. אנחנו רואים מעגל LCR שנבנה, יש המון ניסויים שמגיעים מוכנים כבר עם ה-Measure Lab, שזה התוכנה בעצם שלהם.
From the circuit. The circuit is this one here.
אוקיי, ואנחנו יכולים...
There's a link between these internal units.
Yeah, internal link here. It's here. Metal plate.
איזה יופי לראות את החיבורים.
The white line means it's connected.
אני יכול להגיד לכם שגם זכיתי.
These two halves are separated from each
Yeah,
other.
of course, yeah.
So,
yeah, but here you have this is the power supply is here. This is the power supply, or what is I think much more easier. So let me measure the voltage over the inductance and the capacitance. Here, I need some of these. In parallel, you can measure the current directly.
Great.
In industries, you use resistors to come from a current to a voltage, and then you can again measure voltage. But here you can directly measure the current in parallel to the voltage without these resistors. Okay, so I want to measure the voltage in parallel to the inductance and so I need to measure the voltage in between these 2 points. The voltage.
I see resistor. What I see over there also?
The resistor is only to reduce the current flowing through the devices.
But it's a capacitor and resistor. Oh, okay.
Resistor, capacitor, and the coil. So inductance and capacitance are the 2 most important points, most important parts in this resonant circuit. Okay, so
Yes, of course.
and then you want to measure the current. So for this, you have to put the current measuring devices in series to your circuit. Okay. Coming from the function generator, going through the measuring device for the current, and then going through the inductance, the capacitance, the resistor back to the function generator, and you measure in parallel to the inductance and the capacitance. You measure.
I like it that you don't need basically you just keep the multimeter functionality because you have.
Well,
It's nice.
so then experiment.
So this is the RLC circuit.
So
experiment.
the in series RLC circuit, you have a parallel one and a series one.
There is a kit you sell which is just RLC circuits, isn't it? Rather than this.
This is that's the RLC is let's say a standard experiment for the electricity in physics, but also in engineering, to understand the connection between inductance, capacitance, and resistance in a alternating current
That's what the
circuit.
RLC stands for. Is that reductance capacitance? Resistance.
Yeah, that's the resistance is R. L is for the inductance and C for the capacitance. So okay. Then maybe we can function generator from 1200 to 2000 hertz with the amplitude of 5 volts in steps of 5 hertz.
Yes.
With a sine, single form of sine, it's an alternating circuit. And then in parallel, we are measuring current and voltage. But for this experiment, part of the experiment, we display only the inductance. The inductance and then not the impedance. Sorry, the impedance. The impedance is the voltage over the current. It comes from a calculated channel. The inductance here set is channel 3 over channel 1. Channel 3 over channel 1. This is what we directly measure. It's a calculated channel, so you can make any function you want here to put any channels you have here. You can take any function you want to create your own measuring channel. in that case, the impedance.
I think I'm going to ask a webinar soon on this equipment. It's interesting enough to have webinar.
It's a good idea to make a webinar, yeah?
Yeah. So many functionality, and of course, it can help out different other persons.
Okay, so now, I think everything's okay. The frequency access has to...
Where's your four?
Is it so small?
Four.
The access is to wait till the generator is 2 kilohertz, and then I will zoom in.
So we are looking for another person. 4 plus. Please check. Okay.
This is your resonance curve. Zoom in. That's the impedance. The steps coming from the signal we use. As you remember, I go from 1.2 kilohertz up to 2 kilohertz in steps of 5 hertz. So 5 hertz. This you see the steps here. 5 hertz steps. So, and this is the first part of the experiment. And then what you can do is, okay, I also want to measure the current and the voltage in parallel.
Should that be a sine curve?
No sine curve. What you get a sine curve if you directly measure the signal coming out of here. But you put the sine curve on the circuit, and the circuit, the signal goes through this as a sine through the circuit under different conditions. There is a condition where everything goes through, and a condition where nothing goes through. It's like a resonance phenomenon.
So on the little blue board, you've got a resistor and a capacitor. What is this device?
This coil
For
the inductance.
oh, okay.
Yeah. What you have in this circuit, that the current goes from that to that every time.
איזה יופי.
That's and there are some conditions where how should I explain this?
Can we make this experiment with a different, for example, resistor?
Of course.
And just put the result one above the other? Webinar. We must learn this. It's
Yeah, the question is now to take the right one.
Change the scale.
For this is given by this formula here, this one, and it's so what you see here. It depends on the inductance and the capacitance, where the resonance frequency is, where this position which for example 0.8 microfarads. Because if I now use this one, which is 100 times higher, not 100, 100 times and 1,000 times higher, then this position goes.
Yeah.
And I have used completely different starting and
But can't you just rescale the x-axis?
let's try. Let's try, and also, for example, we have to.
הוא מריץ כרגע את הניסוי עם קבל שונה, קבל שלמעשה הערך שלו הוא פי 100, פי 10 יותר גדול. כמובן שאנחנו נראה את התוצאות במקום אחר בסקאלה בכלל, ולכן הוא גם יעשה איזשהו קיול או טיוב של הגרף, תוך כדי שהתוכנה מציגה את הדברים בצורה הטובה ביותר. פשוט מגניב. תכף אנחנו נראה את זה גם רץ על המחולל, רגע. אוקיי. אז אפשר לראות את המחולל שרץ במקביל.
This is the first measurement. This is the second one. To use 100 times larger capacitor. 100.
So that's 47. Can we just try it with 470? So we started off at 0.4. Oh,
Normally you can also use the middle one.
אז באמת בזה נסיים.
Yes, haben wir Termin, ne?
אנחנו נפרסם בקרוב גם, יש לנו חודש וובינר נוסף שהחבר'ה פה ישתפו אותנו, וזה ממש ממש כיף להיות בהשתלמות הזאת עם החבר'ה המקצוענים האלה. פשוט יפה.